Okay. Okay. Hi, everyone. Uh, I'm Nitish, and today I'm here to present on like how you can integrate uh, LLMs into your uh, applications for a better user experience. And so, a bit about me. Uh, so my background is mostly data engineering, and I'm currently working as a developer advocate at Couchbase. For those of you who are not familiar with Couchbase, it's a document database with which is quite similar to MongoDB in terms of what you can achieve with it, but like we have a different architecture, so it's much more performant at higher scales. And in the developer uh, relations team, what we do is we build a lot of integrations with other tools that developers are familiar with. So building things like IDE plugins or building things for vector search and AI and so on. I'm based in Munich, and I also run a meetup called PyData Munich. So coming to today's agenda, so there's like a lot of different things happening. So I'll walk you through like the motivation for using large language models in your applications, and then I'll go through like three different techniques, basically prompt engineering, rags, and agentic workflows. Yeah. And so over the last 1.5 years, generative AI has been taking off quite a lot. So there are like large language models and like all kinds of different models to do all kinds of different things like generating images, generating videos, uh, generating code, and so on. So, I mean, there are, just a brief overview of what large language models are. So these are models that are trained on huge corpus of data. And by huge corpus, practically the entire internet, all the books and all, practically all the public websites, even including some private websites that the models were not authorized to. So they're extremely good at working with text. And like some of the common examples are like GPT-4, Llama 3, uh, Cloud, Gemini, etc. So LLMs are powerful for certain use cases. And if you can combine these use cases, or if you have a use case similar to these in your application, you can combine them. You can use LLMs to provide a lot of difference to the end user. So some of the common examples are like chatbots. Uh, you can summarize content pretty well. You can do classification of content. For example, you have reviews on a social media or like product reviews, for example. You can get the sentiment of the product based on this analysis. This is like a study that I took from the internet. So Klarna, they basically use LLMs for, or like AI for their uh, customer service use case. And according to their report, uh, it could handle things quite well, and it was quite. I mean, people couldn't really. I mean, the end user experience was not too different from what they would get from a human customer service agent. And yeah, these are more examples. Like you have coding assistants like Copilot or Zencoder. And this one, I'm not sure if many of you have seen this. So this is like pretty recent. This is like a project called Notebook LLM, which is from Google. And basically, it allows you to provide like a lot of resources. You can specify like web pages, URLs, YouTube links, all kinds of things, and you can ask questions about it. You can also generate a podcast even on it, and this is quite cool. Yeah, and as with all things, they also have their issues. So these are just a couple of things that I found on the internet. So one was like Amazon. They had deployed a model that allowed you to search for things on the reviews. But as it turns out, you can do much more than that. So, for example, you could use it to generate code, or, yeah, I mean, you can basically, the LLM was not tuned to just respond to reviews. And there's another case where someone was, so this was like from a car retailer. So they had a chatbot which allowed people to get help in picking what they like. And apparently, this guy just hacked or hijacked the prompt and asked it to uh, agree to the customer, and basically he got a car for $1. Okay, so with that, I'll tell you go through like 3 techniques and how you could use them in your applications. So the very first one is prompt engineering. It's probably the most straightforward one. You are essentially guiding the LLM to perform a task for you by providing specific instructions. Yeah. And this topic is quite vast. Like, for example, this was a paper that was published, I think, earlier this year, which covered like all the different prompting techniques. And there are like more than 40 different categories. And these are just for text. So in this talk, I'll just cover a couple of things that might be interesting for you. One is like output structuring, which means that you can ask the LLM to respond in a certain output, for example, like JSON or YAML, for example. And the other thing which I would show is like the concept of zero-shot and few-shot prompting. So the idea here is you provide some examples of the outputs that you would like from the large language model, and the model would adapt to providing them. With zero-shot, you just don't have any examples, while for few-shot prompting, you provide like a few examples, and based on that, the LLM adapts to your answer. Okay. Oops. So let me just quickly show you a notebook. Yeah. So this is like just using ChatGPT or like GPT-4o, and I have like a conversation here. I'm using so for those of you who are not familiar with this is like LangChain, a framework which allows you to switch between these LLMs quite easily. So here I ask a question. Yeah, so you have like a system prompt, which is like you're a helpful assistant that answers users' questions. What is photosynthesis? And you get like a scientific answer. And if you want to, so I mean, you can do other things, like you can instruct the model to answer like a 5-year-old. So this is like inspired by this. I explained like I'm 5, Reddit, yeah, forum. And yeah, you get like a smaller, much more accessible to a child answer. So photosynthesis is like a magic trick. Yeah. And I'll also show you like the zero-shot prompting and few-shot prompting. So for example, you have here, this is like the prompt is provide a summary of historical events as if explaining to a 5-year-old. And yeah, so I mean, you get like some text. So yeah, I mean, it kind of covers like that the war lasted for 4 years and so on. But you can actually provide like some examples. So for your example here, there is like the American Revolution was when people in America fought to be free from British rule. And then World War II was when many countries around the world had a big fight, and in the end they worked together to make sure that no one could start another huge fight like that again. And based on this, now if you generate the output, it would be slightly different. So this is kind of what you can do with like few-shot prompting. So you can provide examples that allows the model to adapt to it. Okay. So, I mean, prompt engineering, it works quite well in practice. I mean, there are some obvious limitations like, yeah, I mean, it has knowledge limitations, either by the training cutoff for the large language model or, yeah, basically that. And or the training source was never part of it. And due to this, it tends to hallucinate. So it can come up with answers which look reasonable, but they are not. And the other thing is like the hijacks that we saw earlier. So essentially, the person could overwrite the prompt. And this is hard to protect. I mean, you can do some inputs. I mean, you can put a prompt to the LLM to not allow anyone to change it. But I mean, still there are workarounds, and it's really hard to protect against it. I mean, some recommendations is to provide context because like LLMs, they love context because they have been trained on huge volumes of text without much context, or like in some cases context, but always context helps. And it's also good to have like concise prompts with things of what it should and should not do. Okay, so the next thing, next technique is RAG, or retrieval augmented generation. So the idea here is that uh, you might want to train, or you might want your model to answer things that it has not been trained on. This could be internal private documents that are not accessible to the LLM, or it could be things that were after the cutoff date for the model training. And so essentially, the core of it is you have these two parts, retrieval and generation. The idea is that you retrieve some parts of some documents or some context that is not part of the LLM corpus from a vector store, and then you inject this into your prompt so that the LLM can answer based on the prompt. So, I mean, in most cases, you would typically ingest your data that you want the model to answer, and then you would basically search for it at the time of query from the user, and then ingest it into the context of the LLM, and the LLM can answer it. Yeah, I mean, so this is the workflow. So you have your custom data, you generate embeddings for it, and store it in a vector store. And then at the time of generation, you basically ask the question to the vector store, and you get like some documents that are relevant to this question, and then you inject this into the LLM context. Yeah. So I'll show you like a short, quick demo. Hopefully it works. Yeah, so this is like a really simple use case where you can upload a PDF and then ask questions about it. So for this use case, I'll just use the documentation from the LangChain website. So I just exported a PDF of it. So I'll just upload it. Yep. And yeah. So what is happening right now is this document is getting ingested into Couchbase. So there's like a bit of splitting of this document because it's a huge document, and you typically want the document to be split into smaller sections so that you have crisp and concise context that is provided to the LLM to answer. I think it might not be working. Let me check the internet. Let's see. Yeah, let me just quickly go to my app. Yeah. I'll just restart it. Yep. So, yep, I'll just upload this document. And yeah, now it's working. Yep. So now I can ask questions like, how can I use Couchbase as a vector store in LangChain? Now, you should typically get like two answers. One that is generated by using the RAG, and one just by the pure LLM. Yeah, it takes a few seconds. Yeah. And in the meantime, we can take a look at the database. So PDF chat. So you can see like the document. So this is how a document looks. So you have some text, and you have the vector embeddings for it. And there should be some metadata as well associated with it. Yeah. And I have like a vector index defined on this that tells you that embedding vectors are like 1500 dimensions, and I want to do the dot product similarity to fetch the relevant documents. And yeah, so now you got like the answer, yeah, to install LangChain Couchbase, and yeah, basically how it should be. And then you also have this answer from the LLM directly, where it doesn't know that you can use LangChain, Couchbase with LangChain. So it is asking you to create your own vector store implementation and so on. Yeah. Oops. Yeah, so that's that. And so these are the typical components of a RAG pipeline. So you have like the ingestion of documents, and you do want to chunk the documents into smaller sections, preferably with like some overlap so that you don't miss any context. So you do this because uh, for an LLM, it makes sense to have like crisp, concise documents that it can process. And then there's like this embedding models that are important because depending on your embedding models, your vector search could be different. Like some models could be better for some use cases. And in the retrieval of documents, you have vector search, which you perform to generate the documents that are closest to your search term. And then you have something called re-ranker. So this is typically used when you have a lot of documents that you want to put as part of your context. So typically you would do like the most relevant documents should be at the start of the context or towards the end, because that's due to the way that LLMs are trained. So they perform better when these most relevant answers are towards the top or the bottom. And for the generation, you just use the ranked documents as context. Yeah, I mean, this is like a small demo. Let's see if I can quickly show you that. Let's see. So this is like just something a bit more complex. So here I just ingested all the Couchbase documentation, and I can ask questions like, what is vector search? Yeah, hopefully, yeah, so it works. So you get like an answer and like some sources on where you can find more information. And you can also ask follow-up questions like, how can I do it in Python? Now, it should detect that it is, I'm asking about vector search in Python, and then, yeah, it comes up with like the code that allows you to do that, along with like link to the documentation. Yeah, I mean, just like a small kind of real world use case. It's the same. So you have like documents that were already ingested. So you have embeddings and then text, which is part of the website, and like information about which page it is and all those things. Yep. So the code is also available, so you can use it if you like. So, I mean, RAGs are more powerful than prompt engineering. Uh, I mean, but at the end of the day, it's again just like an efficient retriever. So it can only retrieve information that it already knows. So it is better than prompt engineering in the sense that you can ingest custom data that is not there. But I mean, at the end of the day, you can't do things like, for example, the code that was generated before, you can't run it. So those kind of things are not part of a RAG. I mean, one thing that might be interesting is like, this is an area of really active research. So how can you measure the performance of RAGs? And this is quite tricky because it's not deterministic. The answers are not deterministic. And there are like two different approaches. One is like human evaluation, where you do some kind of, let's say, thumbs up, thumbs down kind of feedback. And like you get like some text field where you can say that, okay, this thing doesn't work, this answer is totally off, and those kind of things. And based on that, you can do something. The other approach that is common is you use a large language model to evaluate the response of a large language model. And there are frameworks like RAGAS that can do that. Typically, you would have like a set of questions and like benchmark answers. And the way it works is you use the LLM to see if the answers, so let's say you can try to identify the important parts of the answer from the benchmark answer, and you try to see if those are part of your context and LLM provided answer. Yeah. And yeah, I mean, it's a bit complicated, but still that's one of the good ways you can use to measure the performance of RAG systems. Okay. So, I mean, the last technique that I want to like share with you is like agents. Uh, so the idea here is that uh, it's a bit more dynamic. So you give the LLM the opportunity or like the freedom or control to observe what is the problem and try to come up with some solutions and then explore them one by one and like based on the uh, results act accordingly. For example, if the output is not what is required, it can try to come up with like a different answer. And mostly you do it with by like you provide some tools or like capabilities to the LLMs, and most modern LLMs they have this capability. And one of the common approaches like React, which is like reason plus act. So you come up with like a chain of thought kind of model where you say, okay, I can tackle this way, and then it basically calls all these tools to solve that. And if some of them fail, it tries to come up with the better ones. Yeah. So here I have like a different example. So this is something called something which so like at Couchbase we have something like SQL++, which is like SQL for JSON. So it's mostly SQL, but like with some extra things because you need to work with JSON, like all the nesting and stuff. And like if someone, I mean, so this could be this is just something that I developed because like let's say you have a non-technical person and they want to get some data from the database. I mean, it's not that trivial to come up with queries if you are not familiar with it. And this is just like an idea of how you can come up with a query and then get the data from the database. So, I mean, here the idea is like, so the graph on the right that you see is like a flow diagram for this. So you start with like getting all the list of collections. So collections is similar to tables in relational area. And then you want to identify the structure of the documents. I mean, it's not purely a schema because in document databases, you don't have this concept of schema. They can be diverse across all the different documents. And then based on the schema, we tried to come up with a query. And then once the query is generated, you run it. And if it is not right, yeah, maybe you get an error. You go back again and try to generate the query again. I mean, that's the idea. And once you get a query that's sufficiently good, you get some output, and that's it. So, I mean, let me try to run it now. Yeah, so hopefully this works. So, I mean, I can ask things like, let's say, suggest me some hotels near Westminster Abbey. Yeah, let's see if it works. I mean, most of the data here is like from the US and UK and France. So that's why, yeah. And yeah, I mean, it will take a bit of time. And in the meantime, we can actually look at, yeah, not this one, yeah. So this is like the whole application from the, yeah, I mean, it's using LangGraph, which is like a framework to build agentic applications. And you have like a state which is getting passed across all these different functions. And each function tries to answer based on what it can. And like you have like list of collections. So this is quite deterministic because you just need to parse through all the collections in this database. And for the schema, yeah, I mean, it's using a LLM. So what we are doing is like sending some documents or like some sample of documents with types along with it, and then sending it to an LLM and asking the LLM to generate the schema. And then once you have the schema, it's trying to generate a syntactically correct query. And yeah, I mean, there's like things like you don't want the user to write to the database, you only want read, access, and stuff. And you can also see things like the output structuring. So you only want like SQL++ query and nothing else, because typically you have like all these extra things. And yeah, I mean, you just invoke it and then you do some cleaning and then running the query and you should get the output. And here, like you have the conditional checks, which is like, yeah, if it's an error, you should go back to generate query again, and so on. Yeah, I mean, now let's see if this worked. It didn't work. Okay, let's try something else. Or maybe, let's see what the issue is. Yeah, I think, yeah, it failed to generate a query, but we can search something else. Find things to do near Buckingham Palace. Let's see. Yeah. This should work, but let's see. If not, we can go to more simpler examples. Yeah. Because ideally we should get like, so in this case, I'm just using travel sample data. So yeah. So you have things like landmarks and hotels and airports and stuff. Yeah, it's still running. Yeah. Yeah. If this doesn't work, let's see. Yeah, but like, I mean, in this screenshot, you can see some of those queries that were generated. So, I mean, things like unnest, those are things that are specific to SQL++, because you want to unroll a JSON. Yeah, so it worked. So you can see, oh, this is nice. I didn't expect this, but yeah. So you had things like select name, activity, address from landmark where city equal to London. And because this data set also has like latitude and longitude, it's also trying to identify the latitude and longitude of Buckingham Palace. And yeah, I mean, you got like, yeah, so this looks right. Buckingham Palace is one of the recommendations. Yeah. Yeah, I mean, then there's like a pub. Yeah. So I'm happy with the answer. But I mean, you can do this for like whatever you like. Yeah, based on the data. Okay. So I mean, so the thing with agents is like, I mean, in theory, it sounds really good. Like you can do a lot, but in practice, like some of these complex workflows, it's not so easy to really model them, and like some even require like human intervention. For example, in the case of like a customer support agent use case, you might not want your agent to like offer something like a free accommodation because of some issue. So this might need like the user to like a human person to approve, for example. And you can also combine agents with RAGs so that like you have more knowledge than what the LLM has. Yeah, for example, in this use case, you can have things like all the different SQL commands or SQL++ keywords and stuff. I mean, one thing to note is that like you always have to check these prompts with these LLMs because even though you test them independently in an agentic workflow, it might look a bit different than what you might expect. Yeah, and so I'm nearly out of my time, so I'll just quickly conclude. So the key takeaway from it is there's a lot of things that you can improve for the end users using these LLM tools. I mean, even if you don't use them, you need to at least keep track of what you can do with these LLMs. And you need to really be careful with privacy considerations, especially in Europe. And this is like a really rapidly advancing field, and new models are getting released every week. And it's really hard to keep up. So, yeah, I mean, this is maybe like some things that you might not have been able to achieve last week might be possible next week. And yeah, I mean, that's always the thing, because these models are getting more and more powerful, and it's really hard to keep up. And yeah, I mean, if you want all these demos, they are like available on GitHub. Yeah, I mean, the last one, I need to still add like a few README and stuff, but the code is still there. And yeah, I mean, there are even examples in Node.js. Yeah. And that's it. Like, I mean, thanks. And if you need to, yeah, reach out, you can reach out. And if you want to use Couchbase, you can use Capella, which is our managed version of database, Couchbase, and it's for free. We recently launched this free tier. So yeah, I mean, go crazy with it. I mean, you can do whatever you want. Yep. And also we have a like a community edition, which is also quite powerful. Yep. And yeah, questions. Thank you.
Hello.
Hi.
A very interesting presentation. These tools are getting more and more use. For instance, in healthcare, I work with clinical professionals that sometimes want to ask some questions related to the data that we have for some patients. A challenge, like you said, is to ensure that the privacy and that no data for other patients or from the database that we don't want the user to know. We just want the LLM to give the answer to the query of the user and nothing more than that. How do you think we can limit the action of the LLM so that it doesn't expose unwanted data to the person that is querying it? How do you think we can approach this to ensure that?
Yeah, that's a really good question. I mean, so there are like even other frameworks, like for example, DSPy. I don't know if you have heard of it. So these are things that are like a bit more advanced than what all these plain LLM frameworks like LangChain and LlamaIndex and all those things do. So what it allows you to do is like you can do more conditions and you can do more validations and stuff. And so that's one option. And the other thing is like always use like a local model, which is like not even connected to the internet. So you get like a bit more privacy. Yeah.
Okay. Thank you. Very interesting.
Thank you.